All right, in this worksheet, we're going to talk about this thing called truth table. So one way to determine the truth value of the statement is by using this thing called truth table. Suppose that Keith was invited to the party. However, his ex Tanya was also invited to the party. So Keith is like, no, he doesn't want to go to the party unless at least one of his best friends, John or Abe, also go to the party. Complicated situation. A truth table will be a good way to analyze whether Keith is going to a party or not. Depends on who else is going. So we're going to have a bunch of different statements. Sometimes it's true, sometimes it's false. There are different combinations of statements. So truth table is kind of useful to analyze like when the whole thing is going to be true, when it's not going to be the case. Let's do a little bit of a review. A symbolic form of a statement. A and B, so here underline and, is represented by a up arrow B in symbolic form. A and B is true when both A and B are true, right? A and B are true statement, right? So again, A and B is true means statement A has to be true and then statement B also has to be true. A or B, underline O, is represented by a down arrow B. It is true when either A or B is true, or even both, right? Another way to think about it is only false when both A and B are false. So A and B are true most cases. Only time it's false is when A is false and B is false and A or B is also false. The negation of A is represented by tilde A. It is true when A is false, right? So A is true means negation of A is false, right? They go together because negation is opposite of A. So when A is true, negation of A is false. I can also say if A is false itself, then the negation of A is, what's the opposite of false? Opposite of false is true, right? So if A is true, then negation of A is false. If A is false, then negation of A is true. So, all right, so how does truth table work? A truth table gives you true value of the complex statement for all possible true values for the single statement. Kind of sounds complicated, so let's look at the example. So let's say statement A, there's a statement B, right? So I can think of 4 different cases when I combine A and B. So either A is true, case 1, A is true, B is also true. Case 2, A is true, but B is false. Case 3, A is false, B is true, and then case 4 is both A, B, and false, right? So generally speaking, when we have 2 statements, my truth table is going to start basically like this. True, 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 false, false, true, false, true, false. So this is a very typical way of starting truth table with 2 statements in it. These 4 rows cover all 4 possible combinations of cases. So as we said before, A and B is true when both A and B are true. Everything else, A and B is false. So coming here, A and B is true when A is true and B is true. That means the first row, that's it. That's the only time it's true. Everything else is false. So when A is true, B is false, then A and B is false. Same for the other way around. And then, so truth table looks like this. So first row represents A is true, B is true. Second row represents A is true, B is false. That means A and B is false, and so on and so forth. So there are 4 different cases. How about A or B? A or B is true either when A is true or B is true, or even both they're true, then A or B is also true. So in order to fill out the table here, the first 2 columns, I kind of start out the same way. T, T, F, F, and then T, F, T, F, T, F, T, F. So that's pretty typical way of starting out. this case is A or B, so if A is true, B is true, A or B is okay. A is true, B is false. Doesn't matter because A is true. A or B is also true. Same for the third one. Only time is false is this part, right? And then for A complement or the negation of A, true, A is either true or false. Negation A is kind of like what we talked about, the opposite of A. So when A is true, negation A is false, and vice versa. Here, I'm going to make a little side note. This is for A and B. This is the only true, right? Only time A and B is true. Okay, writing is pretty bad here. And for A or B, you notice that this part is only time A or B is false. So sometimes I remember it like that. For A and B, only time it is true is when A is true and B is true. For A or B, only time is false is A is false, B is false. False. All right, some remarks here. When truth table involves two statements, we usually put TTFF for the first column, TFTF for the second column, so that we cover all possible combinations, right? If the negation of the statement is involved, sometimes we add an extra column. When statement gets more complex, we can add extra columns here. We only have 3 columns, but later we're going to add more columns when things get more complicated. The last one, when is the only row that A and B true? I'm going to say what is the only row, the TT. And what is the only row that has A and B false? A or B false? The last one, FF row. Okay. All right, let's look at number 3. Consider the given situation, given statement. J means Jamie goes to the party. S, Stephanie goes to the party. Create the truth table for the following statement. Okay. All right, go to party if Jamie goes but Stephanie doesn't go. All right, so Jamie goes but Stephanie doesn't go. Again, this is true in logic, but is basically the same as and. So Jamie goes and Stephanie doesn't go. So if I were to translate, Jamie goes and Stephanie doesn't go, so it's negation of S. Right? So again, I'm going to start like this. T, T, F, F, and then T, F, T, F. So that part is always kind of the same. If you have 2 statements, I'll start like that all the time, basically. Here it involves negation of Stephanie, not Stephanie. So I'm going to make that extra column here. Right? So again, negation of S, I'm just going to negate what S is. So T, negation of T is F. F, negation of that is T, and so on and so forth. So if you look at it, I'm switching everything here into opposite of that, right? So now what we're doing is, my statement is J and not S. So basically I'm looking at this column and this column. So I'm looking at J column. I'm looking at not S, negation of S column right here, right? So again, this is and. Only time something and something is true is when both 2 columns are true. So here I'm going through the rows and I'll figure out when I have T and T. This one and this one, the second one. That's the only time I have TT. Notice that I'm not looking at this column anymore because here is a negation of S column. So I'm looking at this column instead. So I'm not looking at this anymore. I'm looking at this. So only time I have TT is this one. Everything else, I don't see anything else that has TT. So everything else is going to be false. So what does that mean? Only time that this part is true, Jamie goes but Stephanie doesn't go, is this case where Jamie's going, Stephanie's not going. Everything else, this statement is going to be false. All right, I'm going to have you pause and work on the second part, part B. And also number four, part B. More things are involved for part B, so I'm going to give you, maybe I can get you kind of started. So part B, I noticed that is this whole thing or this negation of B. So first of all, it involves complement of, negation of A. So I'm going to write negation of A. And then I'll look at this whole thing. So basically what I'm going to do is I want to have a column that has this thing in it. Then I want to have a column that has this thing in it. And it basically is that or that, right? So I want to create a column that has this in it. And I want to create a column that has this in it, right? So let's see. And in order to create a column that has this in it, it's going to be slightly more work because then it involves negation of A and it involves B. So here I'm going to make a column with negation of A and B. And then I'm going to look at the column that has negation of B. So basically I want to look at this column and I'm going to look at this column. And it's basically or, right? It's basically this column or this column. So that's my final answer. Negative A and B or not B. So I'm going to have you finish the rest of 3 and 4 and we'll meet back at number 5. All right, now let's look at the case where it's slightly more complicated when we have 3 statements. So Abe goes to the party, John goes to the party, and Tanya goes to the party. So now there are 3 people involved. So to create a truth table for 3 statements in it, now we're going to need 8 rows. So we're going to do, this is how we're going to start. So Tanya, Abe, and John, T, 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 F, 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 T, T, F, F, T, T, F, F, and then TF, 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 TF. This is to ensure that I cover every cases. So look at the first row. TTT means Tanya goes, Abe goes, and John goes. The second line, Tanya goes, Abe goes, but John is false. That means John's not going. How about the third line? Tanya is true, so Tanya is going. Abe is false, so Abe's not going. John is true, so John's going. So on and so forth. So this is all possible combination of 3 people. So let's say rewrite the given statement in symbolic form and create a truth table. So if Tanya doesn't go, or, I notice this or, either Abe or John goes to the party. Okay, there's a lot of or. So this and this, right? So this is what's going to go. Tanya doesn't go, so negation of Tanya. It says or. And it says or what? Abe or John goes to party. So Abe or John. I'm going to put the parentheses around because it's Tanya doesn't go, or the second part is Abe or John, right? So I'm going to put the parentheses around. So this is a one group, the way it's phrased, right? And there's a Tanya not going, or either John or Abe goes. So if Abe goes, then that's good. If John goes, that's good. Right? So this is going to involve a lot of stuff. So first, so I'm seeing this. So I basically need the negation of T column, and then I'm going to need this column. And then I'll do or. So when it's kind of complicated like this, I have to kind of look at like structurally. So it's like, oh, there's negation of T, and there's this whole thing, and then we'll do or, right? So I need this column, I need this column, and once I have these 2 columns, then I can use or. So let's see. All right, let's do negation of Tanya first. So Tanya is here. Negation of Tanya is I'm just negating everything here. So T will become F, T will become F, F will become T, and so on and so forth. So I write F, 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 T, 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 T. All right, next I need A or J column, so A or J column. And remember, only time A or J is false. A or J is mostly true. Only time A or J is false is when both A and J are false. So there's my A column. There's my J column. So I'm going to look at the cases where they're both false. So let's see here. Oh, there we go. The fourth one, and then what else? The last one. So this is false for this, and this is going to be false for that. So F, F, F. And I think that's the only time when they're both false. This, the fourth row, and then the last row, and everything else either true, false, or true, true. So everything else is going to be true. So true, 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 true. All right, I think we're almost done. So we need not T column, which is right here. And then we need A or J column, which is here. So basically, we are comparing these two. Kind of same. This is OR. So only OR is mostly true. Only time they're false is when you have FF. So I'm going through these two. I'm comparing these two columns. I want to see if there's a case where it's false. Oh, this is it. I think everything else has true in it. So this is the only time it's going to be false. So that's false. And everything else is going to be true. So Tanya, A or J. So everything is true. So my final answer, everything is true. There's my final answer. Maybe I should highlight this. So everything is true except this part is false, right? What's the interpretation is, if I'm looking at this statement, Tanya doesn't go to party, or either Abe or John goes to the party. So only time that's only time that's not the case is this case where Tanya goes, Abe doesn't go, John doesn't go. Everything else, this statement is true for everything else. The only time that this statement is false is when this one, so Tanya goes, John doesn't go, and then Jamie doesn't go. So that kind of answers the next question. When are the cases that I go to the party? All the cases except when Tanya goes, John doesn't go, and Abe doesn't go. All right, I'm gonna have you pause and finish part B. Part B will require also, it has 3 statements involved, so it's gonna require the big table with 8 rows, and then same for number 6. I'm gonna have you finish the rest of the worksheet, and that's the end of the worksheet.